introduction, and let's get started with welcome definition. Diagnosing antibiotics in the audience population is quite challenging due to the overlapping symptom with normal chronic aging, leading to high positive rate in model, also known as high overdose rates. This increases radiological load and healthcare costs for patients. So our study aims to mitigate this overdiagnosis in CNN variable to improve its fairness and reliability. Our approach called C-REDOC, processing device algorithm consists of two components, calibration and group-specific threshold optimization. First, we apply plot scaling to calibrate predictive probability. To ensure that there are more reliable. Next, we optimize the decision threshold for older age group through optimization problem. So our goal is to optimize threshold of this threshold for older age group to minimize their false positive rate, but while keeping their false negative rate as possible. So to achieve that, we define an optimization problem that minimizes the absolute difference between their false positive rate and their overall false positive rate at the standard threshold 0.5. Subject to condition that their false negative rate doesn't go beyond their overall false negative rate at the threshold of 0.5. So imagine you have a train model, you have a validation set, and you have this optimization problem. Like how do you solve this to get the optimization threshold down? So in this study, we use the CDF, cumulative distribution function, predictive probability for C and for 80, like for positive sample, 80 and positive sample, C and cognitively normal, cognitively normal for short, and in the validation set, within each older age group, they have to calculate their false positive rates and their false negative rates, and I showing the formula in the slide. So let's move to the experimental setup. Yes. Yeah, so in this study, we use the RB data set within groups T1 with MI. There's scans of CD and AD subject categorized into four different age group. As you can see in the slide, in this data set has the prevalent shift. So meaning that if you use it using one single threshold for the entire population might not generalize well, so leading to disparate performance. So I use like preview 3D CNN data set developed by Vien, and we call it designed to diagnose AD with 5 convolutional layer and 3 fully connected layer. This model is like widely recognized benchmark in AD classification. However, it suffers from poor calibration and high overdiagnosis rate. This issue leading makes it a kind of an ideal candidate to test the effectiveness of our proposed methods. So this plot illustrates the histogram and the CDF of AD and CN group segmented by all age and older age group. So the vertical lines represent different threshold, 0.5 for all age group and optimal threshold for the older age group. So as you can see, after we apply the tailored optimal threshold, the performance of the older age, like for the their composite rate, like reduce like significantly. So, but however, like their false negative rate, yes, like not without substantial like decreasing. So let's move to the result. So as you can see here, the here is the baseline model calibration curves for the ODI group, they are are below the diagonal, so indicate that they are they are over forecasting and poor calibration. So the model tend to predict higher predicted probability for the older age group, leading to high false positive rate. So specifically, you can see here the baseline, the false positive rate for 75 to 84 plus, the false positive rate they were around 38%, and for 85 plus, their positive rate was around 40%. So this is pretty high rate. So after that, we then apply CBB, calibrated equalize or power testing that is common used in common widely used in rebalancing technique. But however, yes, it reduced the gap between a group by increase the error in the younger population that result in a well-known leveling down effects. But in the contrast, our model improves significantly performance for the older age group. So as you can see here, their calibration curve much closer than their goggles, so indicating better calibration, and their false positive rate for the 75 to 84 group age group reduce 11%, and for 85 age group is reduced 8%. So in conclusion, C-Resolve effectively reduce overdiagnosis in CNN-based model for AD diagnosis for the elderly. So future work we aim to explore the book in other demographic group, and also in other model architecture, and also in other medical conditions like BNCI versus MCI. So here is the QR code to our code of our paper. So thank you for listening. Yeah, exactly. Yeah. So I will come back to this. Yes, because in the older age group, the model right now, the baseline model was suffering from high positive rate, which means that you need to a higher threshold, and that's why I use the research the base survey from 0.5 to 1. So imagine if you want to work on another young age group, and you can refer the optimization problem, and you can get with a lower rate if you want to view it for negative rate.
The optimal tau that you found, was that distinct for going to CN and the AD subgroups?
No, we use both estimate distribution estimation. Yeah.
Did that having finding a particular threshold or having interest of it, you put or something in the path forward, and to adjust focus subgroup prevalence differences, because I guess you can find so many different subgroups which will have different prevalences in one group. So you can, it seems unrealistic to always find an optimal threshold for each individual subgroup.
You mean the limitation of optimize threshold for each subgroup? Is that
do you believe such a method should be applied for all subgroups where you find a different prevalence?
Yeah, I think because depend on I answer you in the way that I understand. If you use the single threshold for the whole population, the thing is that they are in that application they have a prevalence shift, which means that we expect they have the distribution of predictive probability across the group, the varies. So if you use the single one, it not work in that case, right? So it's much better to work in for each subgroup, but of course, every method also have disadvantage if you have a limitation data or maybe the problem like non-convex. So